I hope Serge has brought his checkbook with him.
Good morning. This is the first of 2 panel sessions at DVCon today. This morning, the topic being discussed is verification in the open source era. My name is Brian Bailey, and I'm a technical editor at Semiconductor Engineering. And it's my pleasure to be the moderator for this session. Thanks, Godin and Annette Collins, for doing most of the heavy lifting to get this panel organized. The rapid success of open source RISC-V ISA has increased the enthusiasm for open source hardware in general. But as anyone who has worked in the industry for long knows, unverified hardware has little to no value. To add to that, the cost of verification often exceeds the cost of design, which itself may be a problem, but that's not the focus of our discussion today. Commercial processors have been through terabytes of verification, utilizing every engine imaginable. They've deployed formal verification techniques when necessary. This is all to ensure high quality IP or chips that can be trusted. While arguments can be made that many companies do not need to perform that level of verification, companies cannot risk their reputation by having buggy products. So significant levels of verification are important for everyone. Another problem facing the RISC-V community is coming up with a conformance suite, which will demonstrate that a modified core deserves to receive the stamp of approval to be called a RISC-V core. That requires a test suite with sufficient coverage to show conformance to the specification without necessarily verifying that an implementation works correctly. Companies that are not set up for this kind of verification can use standard implementations that are pre-verified, or they can obtain custom cores from a number of commercial companies that are set up to perform the design and verification obligations for them. A lot of people like the concept of open source verification environment, and that is what we are here to discuss this morning. But what is an open source verification environment? What is necessary in terms of open tooling? Which is more important, open source tools or open source verification suites? What is the right methodology to use for open source verification? Would it have to utilize only open source tools? Or can we assume that companies already have the necessary tools? Even though we may be talking about open source verification of a processor core, what happens when that is now integrated into the system and we have to take on much larger verification role? Now, you saw the slides scrolling at the start of the session, so I will not be doing long introductions to the panelists. Most of them are well known to you already, and they hardly need an introduction. Each panelist will be given the opportunity for a short explanation of their opening statement. I have several questions prepared for the panelists, but this is your session. It's here for you to ask the questions, get the answers you need from these people. So please answer, or please put those in the Q&A box and I will submit as many of those as I can to the panelists as we have time for. Excuse me. Use the chat button to report issues with the session. If you put your questions in there, I'm not going to see them, so make sure you put them in the Q&A panel. The panelists may also provide more in-depth responses in the days that follow the session. So even if we don't get to the question you put in, please do check back later, and there may be more personalized responses to those questions. So to get the discussion rolling, we have a panel of experts from several different fields within the industry. In alphabetical order, we start with Jean-Marie Brunet, who is the Senior Marketing Director for the Scalable Verification Solution Division of Siemens EDA, formerly known as Mentor. Jean-Marie represents Big EDA, emulation, tools, one of the drivers for the standards on which our verification methodologies are based. Would you like to say a few words, Jean-Marie?
Good morning or good evening, everybody. A few words from the context of the panel topic here is, what open source verification mean to us, Siemens EDA, and most precisely in the hardware assisted verification domain. It's really business as usual. You need views, you need RTL that compiles, you need test bench that runs, you need QEMU models so you can do hybrid. It's not too different from the sense of a hardware assisted verification, emulation, prototyping provider. But I'm sure we'll have more topic later on to discuss on what is actually different. But from a high level standpoint for what we do, it is not too different.
Okay, thanks, Jean-Marie. Next up, we have Ashish Dabari. Ashish has been a driver in the formal verification space and is now the founder of Axiomize, an independent consulting company helping other companies with their verification methodologies. Ashish.
Hi, yeah, thanks, Brian, and welcome everyone. So I have a few points to make. I know we are not going into the cost side of open source verification, but I just want to highlight that open source doesn't mean everything is free. And in the context of test and verification, tools that are open source also do not mean automatically translation into high quality verification, as using these tools takes expertise to develop and a lot of human effort, which we cannot overlook. And I think in the context of open source design for hardware, it's a lot different than software because software can be patched up, whereas hardware can't be. So this brings me to the quality side of verification, which is very important to emphasize, because once people get used to a bunch of open source tools and lots of clever people put their minds in and get verification done, what is really important in the context of open source, and much less so in the context of proprietary development, is this aspect of visibility, transparency, and reproducibility without getting a vendor lock-in in place. So any tool could be used to reproduce the results, the verification plans, the strategy, everything is transparent. I think this takes a lot of effort and it largely gets taken for granted. So if we can actually do this level of work, which is transparent and visible and is of high quality, I think a lot will work out quite nicely.
Thanks, Ashish. Simon Davidman needs no introduction. Simon and I first started working together almost 40 years ago now. His latest company, Imperus, has been providing a lot of support for RISC-V and other processors, making reference models and simulators available and putting test suites into the open source domain. Simon.
Yeah, I mean, I guess so. It's an interesting sort of question for this panel, open source verification. I mean, from an Imperus point of view, our focus really is about software and helping people get software up and running. And what happened with RISC-V, we just saw it as another ISA 4 or 5 years ago. We have 13 or 14 we support. And then we realized actually that all the interest around RISC-V wasn't about software, it was how people can design the processes. So then we sort of switched more into verification around RISC-V. And the question for me is about quality open source hardware, really. And the idea of open source verification is, it's sort of easy about it. Yeah, I make money selling verification tools. But when you're building verification with the challenges of these modern SOCs and processes and arrays of processes and everything, the challenge, the cost isn't the individual verification tools, it's actually getting the verification done. And, in reality, you should buy, borrow, beg, anything you can to get better quality. And if it's open source, great. If it's commercial, you should use the best technologies available. So to me, the open source question in verification is not a, it's not, I know Serge is going to say, hey, I want millions of simulators for free. Okay, I probably don't agree with that one, but we'll come to that when we get into the discussion. Yeah. You're on mute, Brian.
Always the danger of using the mute. Thanks, Simon. So next up, we have Tao Lu, who is a senior staff hardware engineer in the Google chip implementation and integration team. They're one of the new generation of system development companies, and they're prepared to challenge some of the more traditional design and verification methodologies. So Google is actively supporting many open source programs, and they themselves have donated tools for RISC-V verification. Tao.
Hi, everybody. This is Tao from Google. So I think this journey started from like 2 or 3 years ago. We see a lot of new open source hardware, especially in the RISC-V world. But what we noticed is that there's no open source verification solution at that time. It's very interesting to see that some people put a lot of effort in putting the design, but we don't see the verification environment around it. That's the problem we see. Then we started to build those sort of open source verification platform for the RISC-V. And it has been an interesting journey. We have seen a lot of challenges, like how do we actually generalize the platform to adapt to different requirements? Because when you go open source, you're not solving a particular problem. You're going to solve a general problem. And a lot of people will have a lot of custom requests. How do you build something which can be customized easily and integrated to their environment easily? And another thing I want to make it that we also got a challenge in terms of open source and free. I think I have a lot of I have some comments on that we can discuss later. But in general, I think open source doesn't have to be free. So open source is something which you make something available, which somebody can do on top of that. But a tooling free is another dimension. So we can talk more about that in the panel discussion. So that's all I have.
Thanks, Tao. Did we lose Bipul? Are you there, Bipul?
I'm sorry.
I think we may have lost the last of our panelists. So we will push on and come back to Bipul if and when he manages to rejoin us. Did any of you hear anything from any other the other panelists? Oh, looks like Bipul is joining us again. Are you there, Bipul?
I am back here. I was dropped somehow.
Hey, Brian, I think I'm next alphabetically.
Oh, I'm sorry, I completely.
Tom said that Leaf.
Sorry, Serge. Okay. Serge Leaf, it's so familiar to me, I forgot he was there. I've been working with Serge on and off for, 30-something years. Serge these days is the program manager in the Microsystems Technology Office at DARPA. His customers are defense contractors, many of which are trying to create products where the volume is in the tens or possibly hundreds. And so they need to find a cheaper development environment. Serge, please go ahead.
Thanks, Brian. So the way I sort of think about this, and is that Moore's law helped accelerate simulation.
We're having problems with Serge.
For a couple of decades. Okay, why don't you go ahead with Vipul? I'll reconnect.
Okay. Okay, so sorry for the difficulties here. So Bipul Talagdar is Director of Applications Engineering for Smart DV. They're creators of verification IP for simulators, emulators, formal tools, and post-silicon validation. Bipul.
Hi, Brian. Hi, everyone. Welcome here. So my point here is that open source verification is a race with the open source design development stuff. Given all the continuous integration and everything in place, a huge community contributing to the open source designs, which makes the design development, at a bullet speed. Now, the challenge of verification engineers to match that pace and to be able to verify, what is out there in the spec. I think there's a huge problem to solve here. Given that, there are so many versions of different, the same design functionality, then the people who want to use the open source design, they need to explore what's out there. And once they explore and select, and then they have to verify. I think that's where the main problem comes in. For verification, there are service engagements available who are monetizing the market. But doing service deal and doing verification done is not exactly, I would say, business as usual for open source verification. Because open source verification in the first place was created to address a different problem, to be, to contribute towards a greater good. To take contribution from different engineers around the globe and build better technology. And given that all in place, the missing piece of verification is something like, I think, a problem to solve there. And that's where I want to mainly center around in this panel.
Thanks, Bipul. Did Serge manage to get back in? No, I don't see him yet. So before we get into questions, so there's Serge. Serge, are you with us?
Can you hear me?
I can hear you, Serge. Go ahead.
Yeah, I apologize. After I make my opening remarks, I'll change the networking.
No,
adapter.
We're still having problems with Serge.
Brian, can I come in through the phone line? Can Nanette send me some kind of password so I can do the phone? Okay, please proceed without me.
Can either Nanette or Tom assist Serge getting in on the phone line?
I'll reconnect again.
Okay, so did anybody in their opening remarks say anything which any of you want to take issue with or expand on before we get into other questions?
I want to mention one thing. I really like what Tao said. To me, open source doesn't mean free. If everybody thinks about open source just a free access to cores, I think it's the wrong way to look at it. There is an aspect that is commercially more advantageous, but it's not about being free. There is no free lunch. So I think it's about interoperability, having access to exchanging information probably a bit more freely in a community, but it's not about free. It's not about having access to things cheaper than if I buy cores from big companies that sell cores. I think it's the wrong approach if we look at that from a cost standpoint.
Yeah, and I'd take that further. I'd say that actually having open source verification solutions gives you a lot more freedom. I mean, it's, okay, I didn't have to pay Tao anything at Google for the generator that he built, but when we were working with customers on their vector processors for RISC-V, we made a lot of use of the technology that Tao has provided under open source. But it wasn't the fact that it was free that was interesting to us at all. It was the fact that we could extend it and change it and make it do the job that we needed and build on all the work that his team had done. And so it gave us the freedom to actually accelerate what we were trying to achieve with our customers. So it was, and that was enabled by the fact that there was source available, so we could change it. So I agree with Jean-Marie and Taria.
Yeah, I agree with that. So we built this environment sort of based on system verilog UVM, which and also based on constraint random. So that means you have a lot of tool dependencies, right? You cannot basically run it with open source simulator at this point. So, but I still think that if you open up something, let's say you have the source code of the generator, then you're actually already adding value to the open source community because people already have the license, they can use it, then they can customize the stuff, right? So if we are shooting for like totally free end-to-end, because we know verification has a lot of tuning you have to support, the regression tool, coverage tool, and all different type of tools. If your goal is to do end-to-end everything free, I think that will take a longer time, and also that will put another restriction on yourself because you cannot leverage advanced features of the commercial tools. You have to go back and limit yourself to do something less performing, that sort of thing. So I think it will be great that to have things free, but I think it doesn't mean open source has to be free. I agree with that.
Hey, Brian, this is Serge. Can I try again? Can you guys hear me better?
Go ahead, Serge.
Okay, so I apologize for all this communication issues. So my quick opening statement is this. I was never a particular believer in open source anything, open source verification included when I was in commercial EDA. But what I have seen is that when people try to accelerate simulation, the general computing performance has always outworked the accelerators as they came about. But at this point, Moore's law is at the end of the road. So we can't expect clock rates to keep increasing. And thus, people are more and more thinking about distributed computing to support simulation and verification, going to the cloud. When you go to the cloud, you have multiplicative need for instances. When you have a need for 1 million licenses, cost of license becomes prohibitive. And thus, in the community that I serve in the defense ecosystem, which is sort of underprivileged community because they don't have any coordinated purchasing capabilities and very complicated contracting, those people seek out open source verification because of cost. One of the programs I inherited is an analog simulator called Zeiss, which is specifically targeted for many instance high degree of parallelism. And I have a growing community that is using it very successfully. And the cost of individual license is zero. So it has, they are able to scale way up. So one of the areas that we are investigating is, should we do something similar for digital simulation, specifically event-driven simulation, so to rethink the simulation kernel so that it maps better onto the cloud, so that it can scale linearly with addition of instances, and so that we can use HPC strategies and maybe incorporate F1 instances and emulators. So in my community, the open source verification is driven by cost.
So I just want to come in, Brian, quickly on Serge's last remark. So it seems to me that there are two themes going on in the panel today. One is driving integration, collaboration, innovation, and the other is the cost side of it. And I would like to ask Sergey if he would like to say anything about who pays for these so-called cheap or free simulators or tools or people who are doing the verification, where somebody's got to pay for it. Who do you think should be paying for it?
Well, so you, the US taxpayer, are paying for part of this.
I'm not a US taxpayer, so thank goodness for that.
Thanks to the others then. But we are investing heavily in open source EDA and open source IP programs. And the reasons for that are multifold. One is to fuel innovation in EDA, which has frankly been stalled since, in my opinion, 1988. And the other is to enable underserved design communities to benefit from essentially scalability on the cloud. So who pays for what? You incur human costs to hire and employ engineers. You pay for that. You obviously have to set up your verification session. Simulation is just one element here. There are test benches. There's all kinds of distribution today that's done frequently manually. It would be nice to have it automated. There's no difference as to who pays. It's just that when I have a customer that's running 1,000 instances and they don't have to pay for 1,000 licenses or go through corresponding contracting complexities at, let's say, a space agency, that's a huge benefit.
So yeah, so I think you have the luxury of the US taxpayer paying for it. So we don't have the luxury in private sector for a taxpayer to be paying for my cost of development. And here is where things get pretty interesting. So we made this formal verification app for RISC-V. It's the only app in the world that works with all the formal verification tools in the market, allows people complete freedom, no vendor lock-in. And yet people expect this to be free for some reason, because it is all part of delivering value to the open source RISC-V ecosystem. So I think so long as the silicon vendors are not offering their processors for free, they should be paying for the services / tools. If the silicon at the end, whether it's soft IP or silicon that gets sold as, as a chip, if someone is commercializing it in the chain somewhere, then companies, whether they're private or public, need to be compensated to sustain innovation. That's my point.
Well, the market should be working for, if you were adding value, the market should recognize it and compensate. So
that's right. That's right. And that's right. And I think I have a creative solution to address this, but we can come back to it later.
And incidentally, US taxpayers are helping you as well, because the open source stuff that we are investing in is available worldwide for now.
I think one of the key things that's coming up here is that open source does provide the ability to have collaboration going on with people. And in verification, this is kind of the first time we've had this opportunity of having a common problem that enough people are trying to solve that there really is the ability to collaborate. Could this actually go a lot further in bringing about some degree of commonality in the way that we approach the verification problem, rather than, I always joke that the U in UVM doesn't mean that everybody does it the same. It means you've got one language, one methodology that encompasses everything that everybody would want to do. Is this our ability to start putting in place some more over-encompassing verification methodology, and it seems that that would have a huge impact on the industry?
I'll take that. I've got my mic off, right? So yeah, I was going to say, I mean, if we just sort of focus on, RISC-V, right? Because it's sort of the open source baby at the moment, right? From a processor open standard point of view, the challenges that there are, and actually as part of the statement on my slide there, was that the problem is that, for the past 50 years, if you built a processor, you did it very secretly. It was very proprietary. You never shared it with anybody. You never shared how you designed it or how you verified it. So suddenly here we are in the last 5 years, as everyone gets onto the RISC-V bandwagon, everybody's a computer architect. Everybody's got an architecture license. Everybody can choose which bits of the standard they implement. And by the way, what's the verification methodology? So actually, so where we are, we've got proprietary solutions hidden away in the big processor vendors, and yet the industry, every chip designer is trying to become a processor developer, and actually they don't have the verification methodology or understanding. And that's why there are solutions coming in. We're building methodologies. We're trying to work with people on sort of standard interfaces so that reference models can be used in a standard way in test benches and stuff. People like Tao and Google are investing a lot of effort to try and build better test generation solutions and make them available in that community. But so I think that there is this basically a dramatic change that's come about because of the open standard nature of RISC-V, that's basically saying to people, okay, you've got to verify a processor. And the problem is they're sort of, okay, we're going to have open source to do that. We've got to, and actually people don't have the methodologies. They don't know. And then if they do come up with open source solutions, you've got the question, who's going to fund this? And it's nice that Serge says, hey, I want infinite free simulation. But it's not a matter of just having a piece of code and putting it in on a cloud. Someone's got to pay for the hardware. Who's going to buy all the computers? Who's going to pay for all of that? So there's tremendous cost, whatever you do with it. But it's not just about building the verification to start with and the methodologies. It's then supporting, maintaining, and develop it. And what's happened over the last 30 years is the EDA industry. And I'm sorry, I don't object, but I disagree with you, Serge, when you say EDA hasn't done anything. It's absolutely phenomenal that we can build silicon the way that we do. The EDA industry has done a tremendous job in getting the products to work. There was a presentation, I went to a conference back in November, and I was absolutely astonished. We found a customer that was using, we don't do open source simulators. We have a freeware version where you can download it. So it's sort of premium freeware, just like Google Chrome is, it's binary, but you can use it, but without license. And, a company, Seagate produced a chip right first time and everything, tens of thousands of simulations every day using our free simulator, and got high quality, piece of silicon out, worked first time, and the verification engineers all kept their jobs, is how the guy presented it. And so I think that, there's lots of challenges, and I'm sorry, I don't buy that open source is the solution for verification. What we need is better verification. We need to move forward. And I think it's great that people are looking at things like Python and other solutions, because AI is going to help us a lot in verification. We just don't know it yet. There's a lot to be done. And it's not the cost of the software, I'm sorry. The cost is in your people, in your brains, and, doing smart things with it all,
So I agree with Simon here that, there is really no open source methodology out there. There is this open source design, but there is no open source methodology. So everybody doing their stuff, building those nut and bolts for open source verification, and they are charging, money for that, of course. But there is no methodology in general. Everybody has their own way of doing things for verifying the open source designs. I think that's where the industry needs to come together and build a methodology. For example, doing simulation verification, people build UVM. Now, this is a unified thing. Now, for the open source designs, what is unified about this verification? I think that's the problem to solve altogether.
Yeah.
I think people, I agree with you, but we should not overlook the fact that we have SAIL development for quite some time, which is an open source industry-led consortium of formally specifying the instruction set architecture behavior. And it's certainly a step in the right direction. I don't believe it adequately addresses all of the concerns that are needed for verifying RTL, but it actually does provide a specification document which is formally specified and formally investigated. So it's certainly in the right direction, but I think it is going to be challenging. I think what Simon has brought up with Google is a very interesting thing, which is Google leading this from the front and helping companies like Imperis improve. I think in the formal space, which is where we work in, we have vendors that are building tools, and then we have companies such as ours who are trying to provide vendor lock-in free world of tools and services, which is interesting. But I think the other point that I wanted to pick on Sergey was his remark on no innovation since 1988. I also take offense to that, because I can tell you that in 1988, you couldn't formally verify 1.1 billion gate design. I can today verify a design as big as that with Cadence tools, for example, or Siemens tools or Synopsys tools. So I don't accept that actually there has been no innovation.
I feel compelled to respond. In 1988, sure. It took 30 machine instructions to evaluate a single event and click the clock. Today, in 2021, it takes 30 machine instructions to evaluate an event and click the clock in an event simulator. In 1988, I was one of the first users of Synopsys logic synthesis and shifted to my organization to design an RTL. Today, in 1921, RTL-based design is still the primary methodology. The abstraction has not moved up. The simulation, which is the topic of this panel, has not measurably improved. There are some open source technologies like Verilator and QEMU that the community finds adequate. To echo what the people said, is I think methodology is where the differentiation should lie within different organizations. And pardon my disrespect for formal, that's not a widely used technology anyway.
Oh dear.
Whoa.
Oh dear.
So Sergey, I would disagree. You said that on formal. You know what? So I was thinking about how we can build a closed loop verification methodology for formal. So how do we quantify the verification and kind of close a loop? Think about a verification flow. That somebody explore and bring in some cores, download some cores and modify, and there is another bump in the core, so you re-download. So there is change in functionality, and now you have your application and you have a moving design that keeps coming in every time the design bumps up. Now with that kind of continuous things going around, we need a quantitative measure to close the loop. Now, how do you do that? So I thought about two approaches here. One was coverage, of course. Every time you bring in something, you look at the new coverage numbers, and you can have some idea on that. What changed, what you did not cover. You need to write more tests and things, and maybe you generate more tests if you have the capability to do that kind of stuff. We do that kind of stuff at Smart TV. We generate tests as well whenever things come in. But anyway, so going ahead, so the other thing I see here is formal. So because formal is the technology that completely analyzes the whole design and can tell you if something has changed the quickest possible way. And I think, having formal coverage and maybe things more, I only could think about these two, can help us bring in a closed loop verification methodology.
And I think you're absolutely right. Coverage is the right way in the context of formal. And just briefly going back to Sergey's point, Sergey, you might not be aware, but at Taxomize, we built this formal verification test bench, which actually can verify, pipeline processors within hours exhaustively. And this is happening today with the tools that Cadence, Mentor, and Synopsys are building. And I can tell you that if you were building microprocessors today and you're not using formal, then something is going to go wrong in the future. And it would be hard for simulation alone to actually find all the bugs.
So I think an objective metric of success of formal verification is business. How much revenue did all formal verification tools generate last year? In the context of a $9 billion EDA market, I assert the fraction is tiny, which to me means it's not widely adopted.
It's not as widely adapted as simulation, but I would let the Siemens guy on the panel comment on that if he has the figures. I don't have the figures.
Well, being part of Siemens, I cannot comment any figure anymore about the level of EDA. So I wish I could, but I cannot. Now, I think one point that I have to agree with what Simon say on the comment from Serge. Without EDA, you don't have advanced semiconductor today. A lot of people were talking about Moore's law collapse. OPC was able to save the mask making process, and we are doing 7, 5, and 3 nanometer today. You have designs that are around 10 billion gates. The largest chips in the world are around 10 billion gates. They are verified with emulation. So there is very key, I will say, advanced development that were done by EDA community in general, not only Siemens, that enabled this. So I think there is innovation in EDA. It continues to be, maybe less visible than a couple of years ago, because there's a bit more maturity with the big three companies. But there is tremendous amount of innovation. So I think, going back to the open source here, it will be interesting to ask every member of the panel is why do we think we need open source? What's the main driver for our industry to go towards open source? And I think we touched a little bit about that at the beginning. For me, it is not about cost reduction. It's about exchange, it's about interoperability, and it's about bringing a community to be able to exchange more information in a control fashion. And I think it's interesting to see that we have representation from DARPA, which is Sergey, on the open source community. When I think open source, I don't think DARPA, I don't think Mil-Aero. So that's an interesting question.
Funny, I think I got two comments there. So first is DARPA probably has a bigger budget than everybody that's on this call, right? So you've got a huge budget, and you're the one who's saying you want everything for free. And the second thing is you're trying to promote open source. And I would have thought the American government and the DoD wouldn't want the world to know what what the latest, greatest bits of technology that American companies are building, right, in
Precisely.
open source that you're funding. I'd have thought you'd want to be secretive of things and build proprietary solutions, not open source ones. But that's a different discussion. I think the key thing, to go to Jean-Marie's question, is it's about freedom. People want the source of something so that they can change it and make it work for what they want to do.
Yeah, I want to ask something back to Brian's original question regarding the methodology alignment opportunity. I think this is a very challenging problem. And also, what's the difference between we do an open source verification project compared with you do an internal project? I think the difference is that you are going to face people from 100 different companies with different requests. So I think we should be thinking about building an ecosystem, that sort of thing, rather than, because unifying the methodology within a company is already challenging enough, right? When you come from 100 different companies, then it's almost impossible to do that alignment. But I think the motivation should be driving some ecosystem which allow people with different methodology to adapt your solution, right? So that will create a much bigger sort of interest for other people, and create much less pain for them to integrate. I think when I was doing comparing the internal project and open source project, what I get, like we are making that for free and we don't charge anything, but what we get out of that, we get a lot of contributions from the community in many different ways, like bug reports, code contributions, feature requests, everything I consider it very valuable contribution. If you are making an ecosystem, and you can actually benefit from a very large team, the whole community, to give you feedback. I think that's the beauty of open source, that you can open up the solution to allow more users that will give you very valuable feedback. And to add to that, I think for the open source hardware development and verification, I don't think we have a good collaboration culture compared with the software world. So I think we need to build that culture so that goes from the original owner and all the contributor and user, everybody has to contribute to this work, then we can make it better. Then you actually get much out of that comparing with you do with 2 or 3 engineers internally in your company. Yeah.
A lot of frameworks and benchmark reference by specific vertical market are considered open source. I mean, if you look at a lot of machine learning, AI, ML, perf, and so on, a lot of reference benchmark are open, and it works well. It's enabling freedom in the ecosystem to compare, and I think the difference is really the design implementation. What do you do with whatever is open internally, but how you verify it and what are the benchmark reference? A lot of them are open and it works well.
I think the benchmarks can be open, but going back to what Tao was saying regarding donating the code, whether it is instruction generator or the full test benches, I think you can do it if that's not your bread and butter. But if you're making money by actually commercializing your offering like the EDA guys are doing, or in our case, I think even in Simon's case, when we're trying to sell tools and our life depends on it, we can't literally just go there and donate it for free. You know, we would like to engage with the community and work with them as in the spirit of transparency and openness and collaboration, as people said, you know, try and bring the coverage story together for formal. But if that's your only business, cost does come into the equation. You know, it's not just collaboration at a cost that actually makes a business run vital.
Can I play to that, riff on that a little bit, Ashish? So one of the things that's interesting in the verification, so there's around what we do, there's a lot of companies wanting to get access to what we do and use it. And we're a member of several different industry organizations. And one of them I think I want to talk about here is something called Open Hardware Group, which is around RISC-V, and its mission is to build open source RISC-V processors. Okay, but it's not just that, and it's got a second sentence, which is for them to be commercial quality cores, and the way that's done is because it uses the best-in-class verification solutions. So, and it's using Verilog simulators, system Verilog, it uses Tao's generator in there, it uses our reference model in there. It'll use any technology it can to build the best quality open source cores. And you know, Serge, you said, hey, Verilator and Creamu, they're adequate. When you're building high quality, adequate is completely unacceptable. You need best in class. Nobody builds, a state-of-the-art SoC using absolute rubbish EDA tools. No, they use absolutely state-of-the-art. That's why it's a many billion-dollar industry, because people know To get their chip to work, they need the best technology. So I'm sorry, when you say a tool's adequate, I think that's it might be free, but then that's like, it's like universities use adequate tools. They don't have the money to buy all the best tools, but actually universities aren't building quality products. No one gets a PhD for building a robust ecosystem around a bit of RTL they've written. They're trying to explore architectures and things. And so when it comes to verification, you have to use the best thing, the best that's available, and whatever that costs, in my view. And that's why open hardware, open source cores, absolutely best quality cores, verified to the same level of quality that you'd find in a big commercial company. And that's why that's exciting. So, open source gives you freedom. That's fundamental. I don't think it saves you money.
Okay, I do want to get some of the questions that are coming in as we talk. At least, some of these are very much along the lines of what we're already discussing. One here from Matt Balance, who says, there's always been an interplay between tools and methodologies. Are we at the point where effectively developing new methodologies involves extending the tools, existing tools, I think he means, or developing new ones? And if so, what is the impact of that on open source tools? So I think that's an interesting question, because it says, do we have the opportunity here to develop some new methodologies that would naturally lead to the creation of some new tools?
Brian, I'd like to take that up. So when I was in EDA, we had a large semiconductor company as a customer who had tens of thousands of servers running simulation around the clock, re-verifying their large chips. And the way they did this is they sliced up not the design, but they sliced up the test suites. And so it was the same design that's being simulated on 10,000 nodes, but the test suites that were running were different. To support this operation, this company had to build up a massive data center and employ close to 100 engineers to support this methodology, to cut things up, to stitch them together, to present them to the design engineers in the morning when things were done. This is an obvious opportunity for automation. With existence of the cloud, with infinite compute and storage, there's no reason to not believe that you cannot automate what this semiconductor company did to create their bespoke solution. So that would be a combination of methodology sort of turning into a tool in a cloud context. I wanted to answer what Simon said earlier. There are multiple types of designs that people do. Not everybody does the state-of-the-art 10 billion transistor, 20 billion transistor chip. Within the US defense community, chips like that do not exist. And within my community, there are research labs that belong to services there are federally funded research centers, there are defense contractors. None of them are scratching on the type of complexity that you're referring to. And yet those all represent underserved market. Okay, you guys, if you really want to find revenue, you should be looking to how to please those people as opposed to pleasing Qualcomm, Broadcom, and Intel, of which there are few.
I just want to quickly add to what Matt asked in the question. So in Maximize, we did exactly what Matt just asked. We built a brand new coverage solution which would run on top of any formal verification tool. And it would actually give you evidence of scenarios that instructions are actually running. And it's a great piece of technology, and it will run regardless of any tool you want to use. So it's an extension, and it builds up on the technology supplied by the formal verification tool vendors, but it's an extension in that sense. So yes, we're certainly trying to make contributions that way.
Yeah, I want to
add into that, so there can be open tools, right? People are opening tools. Say Verilator, for example, is a simulator which is open, but you still need the other nuts and bolts for it. Like you will need verification IP, which will run with Verilator. So I think there are multiple components to a total solution. Going back to what Tao said, building an ecosystem, I think that needs to evolve, building an ecosystem for open source verification, and that will have multiple different things to achieve within, like opening tools, building nuts and bolts for the tools, and how to monetize all these things. And that's a hard problem, and that needs to be explored as well.
Yeah, I want to add a little bit to the opportunity for new methodologies. I think that's a very good point, because I think constraint random has been around us for like 15 years, something like that. UVM system verilog, that's sounds like standard verification solution in the simulation world, right? So, but things are changing, right? So there are a lot of, when we do the open source stuff, then it's surprised to me somebody used my platform to do machine learning based verification for some reason. And also there are new things, and there are people looking at the Python based constraint random, and there are chisel based design verification. I think we need to be sort of open-minded to the new design verification methodologies, languages. So I think this is a part that the traditional EDA commercial tools are not kind of reach too much. So there's a lot of opportunity over there, and there's less tied to commercial tools. So I think there's another opportunity looking ahead of jumping out of the constraint random system where constraint random were and looking for something else.
Yeah, no, I'd go with that. In fact, I watched a paper yesterday by some of the guys that are not on this panel, but I can see its face on my screen here, a paper yesterday about, the use of Python as a UVM verification solution sitting on top of an HDL simulator. And I think, that's making use of UVMs sort of open, Python's, and stuff like this. And so, I think the big EDA vendors absolutely are looking into they're trying to find the best solutions for their customers. Absolutely. You got to think that, using C++ as a modeling technology, that you don't have to buy a C compiler, right? And they do that with their system C stuff. So I think big EDA is not got its head in the sand. I think it is looking at the way the future is changing and it's trying to find good solutions. And I take Serge's point. Yeah, not everybody's building a state-of-the-art chip, for sure. Yeah.
Okay, that brings us to a question that Mark Lasser kind of brought up, and a natural extension of that, where he says one of the most popular verification tools in use today is UVM, which is available via open source. It's been wildly successful and beneficial for both users and tool vendors. System C is another successful open source verification tool. Are these the models for future tools?
From my view, it doesn't really matter what's the language we are using. And so behind everything, right, we are talking about constraint random verification or formal verification, right? It doesn't matter which language you use. So I want to add to a little bit about Simon's comment on Python and that sort of stuff. I think, and also add to how does the open source tooling compete with commercial tool? I think it's unfair to say that we want to get the same feature set and better performance from the open source tool compared with commercial tool, because the investment is totally different. But you can definitely build something which is good enough and with reasonable performance and lower cost, right? So that's, I think, an opportunity. You don't have to do apple-to-apple comparison to say, okay, you have to reach to the commercial level, the big company, commercial EDA company, that level in order to succeed. You can definitely do something in the middle and make something successful. Yeah.
I want to add to that. So looking at today's design methodologies, things are changing. People are designing at the higher level of abstraction and generating designs. It's no more RTL is the primary way of encoding a design. So given that, that's the assumption apparently for today's tools. And I think the tools need to evolve, starting now, to be able to handle something a larger scale where you will be generating your designs from a higher level of abstractions, and you should be able to do verification at that level. So to be able to generate test as per the spec you are designing at. So I think, and today we are given that primitively enough now RTL is the main entry of design. That's the assumption of all the tools, and now we are kind of modifying the tools to be able to handle something like a design methodology, be it like CGL-based methodology, be it blue spec-based methodology. We're kind of retrofitting stuff. And I think that there needs to be a revolution in the tools world to be able to verify at higher level of abstraction and generate tests as well together with designs.
That's already happening. I mean, we're able to do high-level synthesis from C to generate automatically RTL that is very good quality RTL that compiles with a simulator and emulator. So it is already happening, and we see a trend of very large companies that spend less time on building RTL and work more at a high level modeling. It is happening.
So I think I can see we're getting near the end here, Brian. I think because I've probably finished a half past the hour, right? So I think we're talking about open source, and we confuse that with free. I mean, the free tools business is a service model, sort of like Starbucks and McDonald's, right? And you have to pay for it somehow. But it's pretty much, I mean, I'd say it's unhealthy if you eat too much of that stuff. You've got to find somebody who's going to develop technology, and the way that technology in EDA is developed is actually through startups, and that is funded by commercial adopters. A service model never really builds anything that's more than just adequate. That's a fundamental sort of structural problem. If all companies just fund free tools, you end up with adequate, whereas if you have startups, they become world class. You just got to look at what we use today in terms of that are all owned now, of course, by the big vendors, but that's just the ecosystem that we live in.
Yeah, as the only large EDA vendor on this panel, I can guarantee you there is innovation within large EDA companies.
So I just want to say that I noticed the question, Brian, come up saying, is somebody going to talk about YOSYS when you're talking about formal tools? And I just want to bring up YOSYS because it's an example of a great formal verification tool. But am I going to use it tomorrow to sign off the designs that I actually sign off with the commercial tools? Maybe. I'm not 100% sure that YOSYS is completely at the same level as the commercial tools. So I'm not saying we'll rule it out or that we won't support it. In fact, we would help in the journey of YOSYS becoming a better tool.
We're not talking
as Sam was saying, sorry, Sam, I just wanted to say you brought up the open hardware thing, and I think the idea there is to use production grade verification, right? And that's what I think we're talking about here, right? So using tools that give you production grade quality.
So there is another area that there's been a couple of questions on, and it does go back to something that people did say in their opening remarks, and it's all about open source coverage database. It's the industry. We've tried to create one of them. We actually understand that it's a necessary part of a verification methodology, but UCIS hasn't been particularly successful or adopted. That would seem as though that's an indication of open source failure in this area.
Yeah, so I think we can learn from what did not work, Brian, and try and make it better next time. I'm certainly hopeful, but we need all the big tool vendors and the small ones to work together on that one.
Yeah, I think open source hardware, I would say we need to find common interest from the tool provider and the users and everything, right? Only when you get to that, you have to, and I see some people ask about how do you get timely support from open source? How do you get commitment from the open source thing? I think that's all important questions because if you want people to, because when we do verification is a very serious business, right? You don't want to have something cheap, but creating problem in your chip, right? So you have to do at the production level verification. So we have to build this common interest so that you can get access, you can get success only when you can achieve product level verification quality. So yeah.
Well, I just wanted to add that from my perspective in the kind of government ecosystem, the open source has appeal for several reasons. One is I have a community that likes to extend capabilities and do so without exposing their extensions to the outside world. Open source allows them to do that. I have almost entirety of my community is unable and incapable of negotiating as a block. So they cannot, even though they're large in quantity, they cannot ensure discounting that their size would warrant. And lastly, and not lastly, and they have very difficult contracting. So open source, the fact that you don't actually have to go through a year of contracting work to get one license of a simulator is a big argument for open source, okay? And lastly, one thing that government has in abundance is cloud computing. We have extremely favorable deals with all the cloud compute vendors. It costs us very little. And this is combination of those factors make open source verification in particular appealing, because now my cost of underlying computing is nothing. And so the dominant cost becomes, $50K per license of a commercial simulator. If I can eliminate that, that actually solves a lot of challenges that I have here. And as far as getting EDA company funded these days by private sources, I'm sure many of you have tried. There's no risk capital available for this endeavor, which sort of suggests lack of belief in the capital markets, in innovation and potential in this space. I, however, am open for interesting ideas. If you guys have any across EDA and IP, this is a unique time at DARPA where somebody from EDA industry is actually at DARPA. And I've invested over $110 million in IDEA and POSH, whose sole purpose was to resuscitate innovation in ideation space. So I'll close with, I'm open for business. If you guys have good ideas, I don't want your equity, okay? And I don't want you to necessarily be open source. I'm interested in moving the technology forward.
Anybody else have anything to add on that?
One comment. I think one of the challenges that I see for the EDA industry with open source is that if a lot of things are common and exchangeable with a lot of freedom, it's a good thing. But at the same time, it's difficult to compete. It's difficult to show something that is significantly better than others if the source is common for everybody. So there's one angle with open source, which has not been discussed in this panel at all, is, how do we continue as EDA industry to compete where a lot of things become open source? We need to compete because we need to drive each other to be better so that the industry continues to drive in the right direction. I see that a little bit of a challenge. It's not very addressed in a lot of panels, but when you move towards some things that are very common for everybody, and how do you actually compete with the from EDA to EDA guys?
Yeah, so I'll just finish. I think one of the things that I've heard, which sort of surprised me, is that we're not clear when we're talking about things, whether we're talking about free lunch or free beer or freedom. Serge says he wants open source, but actually he doesn't want open source. What he wants is free. And we have to be clear on that, because we absolutely need what Jean-Marie says. We need open source because we need the freedom to do things. It doesn't have to be free. And I think we need to be careful when we talk about free and freedom, right? There's many companies sell RISC-V IP, right? Well, the ICE is free. Why are you selling your products? Well, because companies need quality processors. So I think that we have to be careful when we talk about open source. The value in open source, I believe, is freedom to innovate. It's not free lunch, free beer, right? That's a different thing altogether. We make a free simulator and give it away. It's closed source. Google Chrome, which most of the world uses, isn't open source. It's closed source. But we use it because it's free and it does better than anything else. And that's what you should be looking for, Serge. You should be looking for technologies, not open source, unless you want that freedom. It's freedom that you want source for. You want the highest quality products. That's what you need for verification.
Yeah, I couldn't agree more. Open source helps innovation, sure. But I don't think it's a solution to economic problems. What I'm having to deal with is structural issues that exist within the government ecosystem. And this seems to be a reasonable solution to some of those problems, though not a complete solution. As you highlighted, making this stuff available to geopolitical adversaries is not a great idea.
Yeah. Anyways, we are a little over time at this point. I would like to pose one final question to each of you. It's if we're considering a RISC-V core, it's of how much could somebody save on verification costs if the test bench was free compared to the tools being free? Which has more benefit? Why don't you start, Simon?
Yeah, okay. I mean, so yeah, going back to the open hardware guys, what they've done is, I don't know, they've had 1, 2, 3, 4 or 5 companies spent the last year building the verification test bench, a UVM test bench of this RISC-V core. that they built, 32. So it's a very relatively simple 4-stage in-order core without floating point or anything very complex. Still 4 or 5 guys from different companies collaborating over a year using commercial tools and everything. But that test bench, all the source of it and everything is UVM available free on their GitHub. Now, you can't run it unless you have a Verilog simulator and all these other things. But what it does, and actually just to Serge's point, they use the cloud, they do it all in regression farming. It's done all through the cloud, through not one of the big 3 EDA vendors, another vendor of Verilog simulators. But so I think that the people, and the interesting thing about open hardware, what they want people to do is say, look, we have the best core, the best quality core that's open source. You can download it and just use the core. But the great thing about RISC-V is you can extend it or change it. And if you do that, then you really need to re-verify. And here is our verification test bank and all the work. So it comes with all the make files, comes with all the tests, comes with all the compliance tests, comes with all the documentation. You know, you can push a button and it will run. And so that they've made all of the efforts of the test bench free and open source as well. But it's not free to run it because you need your HDL simulators and things. They use the best quality tools, but the test bench is free, like the model is, the RTL is free.
I think we need to be sort of, I don't know why we need to compare those two, because I think the first thing is that if you get open source test bench, that give you benefit of, I would not say complete verification. It could give you right away something you can verify to 90 or 95% of the chip. So that's a big saving, because I don't think people just use open source solution as their only solution for the verification. They have their in-house solution, but they use that for free, so they can just plug in and do a lot of things. If they can find bugs out of this solution, it's a big win, because you don't have to, it's kind of complement your in-house solution. I think that's definitely value for the users. In terms of the tooling, I think that basically it depends on the availability of the tool, what people want to use, right? So you have to find a sweet spot in terms of cost and quality, right? You don't want to just compromise the verification because you don't have. So if you have to use a good tool to do the thing, you have to use it. If it's available in the open source market, then that's great, because that will give you additional saving. I think that's two things.
Ashish.
Yes, I think tools or services, there's no free lunch. We contributed to the open hardware work, as Simon mentioned, from Impera's side. We used our app to formally verify every week. If there were any changes in the design, we were able to turn it around. Of course, all of the work we did was for free, and services was free. And thanks to all of the EDA tool vendors, Cadence, Mentor, and Synopsys, donated tools to us, so we were able to use it and check the results on all the tools. But building formal verification test benches, I believe, much like UVM test benches that generate high quality proof convergence and give you predictable results, requires expertise and innovation. And we couldn't be doing this forever for free. So that would be my closing lines on that one.
Vipul.
So open test bench, or it is just free test bench, right? If the test bench is open, then the user can modify it, right? So if the user can modify it, I will just take that and make it, work with something like a Verilator to have a completely free solution. I mean, that's how I would think it. But somebody has to do the job, so you have to pay for that at least, right?
So,
well, I don't think anything should by definition be free. So people who have put effort into doing this, they should be rewarded for those efforts. What I would assert is that there's been very little, just like in EDA technology, I'll stick with that, there has been very little innovation in business models that surround EDA. And it's not really a question of free, it's finding the point where your value added and the customer's ability to execute business with you need to match. And that may be free with support that's annualized, or it may be some kind of freemium business model, or it may be deferred revenue. I don't know. But what I'm saying is that the concept of free is not really a relevant concept here. It's an artifact of a business model. If people are doing stuff as a hobby and they produce free things, the quality expectations should be correlated to what you get. Anyway, so to me, I don't want to answer that question because I don't think you can impose that anything should be free. If something can be free as a result of an effective business model and it benefits the producer of the value and the consumer of the value, that's a great economic equation.
Last words to you, Jean-Marie.
So I think it's interesting. We started by saying open source doesn't mean free, and the last question is about going back to that topic between the design and the test bench. So I think open to me does not mean free. It means freedom, as Simon mentioned. I think there's a shift a little bit of where the spending is. There is some adjustment, maybe fees not directly to access to a processor, but redirected differently because you get what you pay for. So if you pay less, you get maybe something of a less quality, or it's a hidden fee. You have to spend more time yourself with engineering costs to validate the quality of what you're getting, for which you pay less probably. So I think it's a shift left towards sooner in the decision process of where the money is spent and how the money is distributed. But I think the amount of money spent is about the same. It's just distributed differently. So I think to me, open doesn't mean free. It's more freedom.
Well, thank you very much to all of the panelists, and thanks to the audience. They did put in an awful lot of questions that we got a small fraction of them covered. I do encourage the panelists to go in and look at the Q&A where they can provide written responses to some of them if they want to. And I encourage the audience to come back later and see whether there are answers to some of those questions. So with that, thank you very much and enjoy the rest of DVCon.
Thank you. Bye.
Thank you.
Thank you. Bye.
Stay safe. Bye-bye.